Previously, we uncovered the scientific establishment's reaction to experiments that failed to detect Earth's motion. The ether experiments of Michelson-Morley et al. All provided results consistent with a motionless Earth. Yet rather than accept this conclusion, mainstream science scrambled for explanations. The Fitzgerald-Lorentz contraction, special relativity, and eventually general relativity, each more complex and speculative than the last. But even as the theories grew more convoluted, the hard data kept pouring in. And in the 20th and 21st centuries, that data came from the one place we hadn't looked before, deep space itself. And the result is the most astounding phenomenon discovered by modern cosmology. For over 4 centuries, the Copernican Principle has stood unchallenged, a sacred dogma of modern cosmology. It declares confidently that Earth occupies no special place in the universe, no unique vantage point. But what if that principle was never proven, only assumed? And what if the very fabric of the cosmos, the motion of galaxies, the distribution of matter itself, is screaming that Earth is not only special, but central? In this final episode, we examine the cosmic microwave background, satellite missions like COBE, WMAP and Planck, and the mounting body of cosmological evidence that points to a truth long denied. Earth appears to be at the centre of the universe. Let's begin with the man credited with launching modern cosmology, Edwin Hubble. In the early 20th century, Hubble made observations of redshifts showing that galaxies appeared to be receding from us in every direction, a discovery that led to the Big Bang theory. But Hubble's own words betray his discomfort with what he saw. In 1937, he wrote, "Such a condition would imply that we occupy a unique position in the universe, but the unwelcome supposition of a favoured location must be avoided at all costs. Hence, the assumption must be made that the redshifts are not due to actual velocities." In other words, the data pointed directly at a central Earth position. But rather than accept it, Hubble declared it must not be true because it was too horrifying. Not because of scientific refutation, but because of philosophical rejection. The Copernican Principle had become a metaphysical dogma, immune to contradiction, even by empirical data. In 1976, the alarming data from redshift observations led astrophysicist Y.P. Varshney, a fellow of the American Physical Society, Institute of Physics, and Royal Astronomical Society, to make the following startling claim in his attention-grabbing paper published in the Astrophysics and Space Science Journal, "The Redshift Hypothesis for Quasars. Is the Earth the centre of the universe?" It is shown that the cosmological interpretation of the redshift in the spectra of quasars leads to yet another paradoxical result, namely that the Earth is the centre of the universe. The Earth is indeed the centre of the universe, the arrangement of quasars on certain spherical shells is only with respect to the Earth. These shells would disappear if viewed from another galaxy or quasar. This means that the cosmological principle will have to go. Also, it implies that a coordinate system fixed to the Earth will be a preferred frame of reference in the universe. Consequently, both the special and general theory of relativity must be abandoned for the cosmological purposes. In 1978, Arno Penzias and Robert Wilson accidentally discovered what's known as the cosmic microwave background, or CMB, a faint, uniform glow of radiation spread across the sky. Their Nobel Prize-winning discovery was initially heralded as final proof of the Big Bang theory. But within the same year, papers began to emerge suggesting something peculiar. This background radiation wasn't perfectly uniform after all. It contained anisotropies, slight variations in temperature and intensity that defied the Big Bang's prediction of a homogeneous isotropic universe. An isotropic and homogeneous universe looks the same in all directions and from every location. An anisotropic or non-homogeneous one shows preferred directions or patterns, something the Big Bang model never predicted. Then came 1981 and the work of physicist David Wilkinson. His analysis of the CMB using high-altitude balloons revealed a striking quadrupole distribution, a pattern of temperature fluctuation that appeared to straddle Earth's ecliptic plane. In geocentric terms, the ecliptic is the path the Sun takes through the sky over the course of a year, centered around Earth's position. This alignment was devastating to the standard cosmological model. The CMB, supposedly the leftover heat of a chaotic cosmic explosion, was aligning itself with Earth's orbital reference frame. That shouldn't happen, unless Earth occupies a unique position. In 1989, NASA launched COBE, the Cosmic Background Explorer, or Explorer 66. Its mission was to map the patterns in the CMB. And it did, confirming Wilkinson's earlier findings. There was a definite structure and alignment to the universe. The CMB wasn't random. It appeared to have been stamped with a frame of reference that aligned with the Earth. Next came the Wilkinson Microwave Anisotropy Probe in the early 2000s, named after David Wilkinson, who discovered the quadrupole. It revealed even more detailed structure in the CMB and brought to public attention what some scientists began calling the axis of evil. This axis wasn't just an anomaly, it was a clear, measurable pattern that pointed directly along Earth's equinoxes and ecliptic plane. We see the concern that these observations were having on mainstream science in the comments of Lawrence Krauss of Arizona State University. He said in a conference entitled "The Energy of Space That Isn't Zero" the following: "But when you look at the CMB map, you also see that the structure that is observed is in fact, in a weird way, correlated with the plane of the Earth around the Sun. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. There's no way there should be a correlation of the structure with our motion of the Earth around the Sun, the ecliptic. That would say we are truly the centre of the universe. The new results are either telling us that all of science is wrong and we're the centre of the universe, or maybe the data is simply incorrect, or maybe it's telling us there's something weird about the microwave background results and that maybe Maybe there's something wrong with our theories on the larger scales. To explain further, in the geocentric model, Earth isn't tilted. The 23.5 degree angle we call the axial tilt in the heliocentric model is instead the tilt of the cosmos itself. And here's the key insight. The CMB, the largest visible structure in the known universe, shows an alignment exactly matching this angle. Only one cosmological model would predict a cosmological significance to this 23.5 degree angle, the geocentric one. In the heliocentric system, this tilt is a purely local phenomenon, a fluke of Earth's axial spin, not something that should show up in the background radiation of the universe. But in the geocentric model, that angle is expected. In fact, it's predicted. The largest structure in the cosmos is aligned with Earth. The Planck satellite, launched in 2009, confirmed all of this with greater precision. Not only did it detect the same low quadrupole moment and anisotropy, but it found that these anomalies lined up with Earth's position, which cannot simply be a coincidence. This was cosmological alignment. So how does a geocentric model explain these CMB patterns exactly? Quite simply, Coriolis force, a real force in the geocentric model generated by a rotating universe around a fixed Earth. Just as the Coriolis force causes hurricanes to spin clockwise in the northern hemisphere and counterclockwise in the southern, so too would it influence the largest structures of the cosmos. The warm and cool deposits of the CMB resemble Earth's weather patterns for a reason. They're subject to the same directional forces. In a geocentric cosmos, this force would extend from the outermost edge of the universe right down to our atmosphere, influencing not only the motion of galaxies, but the heat distribution of the universe itself. It would even impact the behavior of pendulums and gyroscopes here on Earth. The anomalies didn't stop. In 2009, shortly after the Planck probe, a groundbreaking study revealed that the spin directions of spiral galaxies also correlate with the so-called axis of evil. Galaxies in the northern sky tend to spin leftward, and those in the southern sky spin rightward, mirroring the Coriolis pattern seen in Earth's hurricanes. Again, this is an alignment on a cosmic scale. The New Scientist publication reported the following. Baffling rows of spiral galaxies that prefer to spin in one direction could have profound implications for our understanding of the cosmos. If the universe does contain such an axis, it would contradict our current view of the cosmos, which assumes that matter and energy are uniformly distributed throughout, and that the universe looks pretty much the same in all directions. A similar bias among structures of cosmic proportions would have deep implications. For example, if more galaxies are spinning one way than the other, this implies that the universe has a net spin, or angular momentum, in a particular direction. Since angular momentum can neither be created or destroyed, the universe must have come into existence in a spin. What set it spinning though, and what is it spinning relative to? Gamma ray bursts, the radio sky, and the distribution of quasars also appear to organise themselves in spherical patterns around Earth's location. These aren't random data points. These are radial, centred, pattern distributions, evidence of a small, bounded, geocentric universe. Jonathan Katz noted in his book The Biggest Bangs the following stunning admission. The uniform distribution of burst arrival direction tells us that the distribution of gamma ray burst sources in space is a sphere, or spherical shell, with us at the centre. Some other extremely contrived and implausible distributions are also possible. But Copernicus taught us that we are not in a special preferred position in the universe. Earth is not at the centre of the solar system, the Sun is not at the centre of the galaxy, and so forth. There is no reason to believe we are at the centre of the distribution of gamma ray bursts. If our instruments are sensitive enough to detect bursts at the edge of the spatial distribution, then they should not be isotropic on the sky, contrary to observation. This is the Copernican dilemma. To this day, after the detection of several thousand bursts, and despite earnest efforts to show the contrary, no deviation from a uniform random distribution, isotropy, in the directions of gamma ray bursts on the sky has ever been convincingly demonstrated. Mainstream science started developing exotic physics in order to explain away 21st century observations. Dark matter was introduced as a possible solution in order to save the venerated Copernican Principle. As Science Daily said in 2008, although dark energy may seem a bit contrived to some, the Oxford theorists are proposing an even more outrageous alternative. They point out that it's possible that we simply live in a very special place in the universe. Specifically, we're in a huge void where the density of matter is particularly low. The suggestion flies in the face of the Copernican Principle, which is one of the most useful and widely held tenets in physics. Copernicus was among the first scientists to argue that we're not in a special place in the universe, and that any theory that suggests that we're special is most likely wrong. The principle led directly to the replacement of the Earth-centered concept of the solar system with the more elegant Sun-centered model. Dark energy may seem like a stretch, but it's consistent with the venerable Copernican Principle. The proposal that we live in a special place in the universe, on the other hand, is likely to shock many scientists. However, some honest voices remained skeptical and began to question the foundations of modern cosmology. Timothy Clifton, Oxford astrophysics member, said in his paper Living in a Void, Testing the Copernican Principle with Distant Supernovae, a fundamental presupposition of modern cosmology is the Copernican Principle, that we are not in a central or otherwise special region of the universe. Studies of type 1a supernovae, together with the Copernican Principle, have led to the inference that the universe is accelerating in its expansion. The usual explanation for this is that there must exist a dark energy to drive the acceleration. Alternatively, it could be the case that the Copernican Principle is invalid, and that the data has been interpreted within an inappropriate theoretical framework. If we were to live in a special place in the universe, near the centre of a void where the local matter density is low, then the supernovae observations would be accounted for without the addition of dark energy. Marcus Chown said the following in his New Scientist article, Is the Earth at the Heart of a Giant Cosmic Void? Dark energy is problematic. No one really knows what it is. We can make an educated guess and use quantum theory to estimate how much of it there might be, but then we overshoot by an astounding factor. That is grounds enough, says George Ellis, to take a hard look at our assumptions about the universe and our place in it. If we analyse the supernova data by assuming the Copernican Principle is correct and get out something unphysical, I think we should start questioning the Copernican Principle. Whatever our theoretical predilections, they will in the end have to give way to the observational evidence. So what would it mean if the outcome were that the Copernican Principle is wrong? It would certainly require a seismic reassessment of what we know about the universe. If the Copernican Principle fails, all that goes with that goes out the window too. Cosmology would be back at the drawing board. If we are in a void, answering how we came to be in such a privileged spot in the universe would be even trickier. Faced with these troubling alignments that reveal the uniqueness of Earth's position, modern cosmology had a choice: re-evaluate its assumptions or invent a new escape route. Predictably, it chose the latter. Rather than accept Earth's centrality, and deeply troubled with earlier attempts like dark matter, cosmologists have increasingly given up on trying to prove that the Earth is not special with regards to our universe, and have turned to the multiverse theory, a speculative idea that proposes an infinite number of universes outside our own, each with different physical laws. But here's the problem: the multiverse is unobservable, untestable, and unfalsifiable. The unflappable George Ellis noted in his piece Dark Matter and Dark Energy: Proposals Maintaining Cosmology as a True Science. However, the very nature of the scientific enterprise is at stake in the multiverse debate. The multiverse proponents are proposing weakening the nature of scientific proof in order to claim that multiverses provide a scientific explanation. This is a dangerous tactic. Note that we are concerned with really existing multiverses, not potential or hypothetical. Two central scientific virtues are testability and explanatory power. In the cosmological context, these are often in conflict with each other. The extreme case is multiverse proposals, where no direct observational tests of the hypothesis are possible, as the supposed other universes cannot be seen by any observations whatever, and the assumed underlying physics is also untested and indeed probably untestable. In this context, one must re-evaluate what the core of science is. Can one maintain one has a genuine scientific theory when direct and indeed indirect tests of the theory are impossible? If one claims this, one is altering what one means by science. One should be very careful before so doing. In short, Ellis is saying it abandons the scientific method entirely. Multiverse is not science, it's a philosophy cloaked in math. The multiverse is the Copernican Principle's final shield, erected not because of evidence, but to protect a dying worldview from the implications of hard data. As Marcus Chown says, it's the only option to escape the bitterest pill for many to swallow: an intelligent creator. But the main reason for believing in an ensemble of universes is that it could explain why the laws governing our universe appear to be so finely tuned for our existence. This fine-tuning has two possible explanations. Either the universe was designed specifically for us by a creator, or there is a multitude of universes, a multiverse. Throughout this series, we've traced the arc of cosmological history from ancient observations to modern theoretical physics. We've seen how every major physical experiment, from Michelson-Morley to Sagnac, pointed to a stationary Earth. We watched as relativity twisted itself into knots to explain away the evidence. And now, the satellites we launched to confirm our cosmological assumptions have come back with a simple, humbling message. Earth is at the centre. The data is not ambiguous, it is coherent. The largest structures in the universe align with Earth's orientation, its seasons, and its equator. The forces that shape our weather, shape the cosmos. The heat maps of the CMB reflect the same Coriolis logic that drives our hurricanes. This isn't chaos, as the Big Bang implies. This is elegance, order, and design. The geocentric model aligns with the observed data, from our telescopic observations to the behaviour of light in real experiments, to the structure of galaxies, to the temperature map of the universe itself, as observed by modern satellites. The battle for the centre of the universe is over, and there is only one clear winner. So I leave you not with speculation, but with a question. If the heavens declare a fixed and central Earth, then is there not someone who placed it there?